Now that you understand the observational evidence for climate change, we're going to look at the subject from a more mathematical viewpoint, using climate models. The output from climate models is critical even to observational scientists like myself. People often say, oh, it's just a model. Well, yes, it's just a model. All models are just models. The question is, what can we do with it? How can we make it useful? Climate models allow us to run experiments on the Earth. It would be unethical and really, really difficult to run an actual experiment on our actual Earth. But once we can validate our models, once we can show that, yeah, they do a really good job of explaining what goes on and where, we can run any experiment that you can imagine through a computer model. Then we can see in the real world if the results are accurate.
We know that there's something else that will probably make the climate behave in a way that is different from the past.
Our guest lecturer will be Dr. Michela Biasutti, a research scientist at Lamont Doherty Earth Observatory.
It's risky to base your projections on past data.
Her work uses model output to figure out how to actually make changes in places like Africa that have been hard hit by climate change. To better understand how climate models work, I'll be talking with you about climate forcings and climate feedbacks. That's what makes the climate system so dynamic. We also have essays for you to read that will explain step by step how climate models are built and how they're used. But rather than just have you listen to us talk about climate models, I'm going to invite you to use some yourself. We're first going to work with a simple dynamic model that will allow you to understand how climate models in just a few lines of code can really capture complex systems. Then we'll look at model output from real climate models that are being used by scientists today. I think you'll learn a lot about how climate modeling works and why it's so critical to the science.